Hello guys, welcome to Coding. In this video, we are going to see the Leetcode problem number 238 odd even linked list. Let's get into the problem. So the problem statement is we are given the head of a linked list, group all nodes with odd indices together followed by nodes with even indices and return the reordered list. So the first node is considered odd and the second node is even and so on. So note that the relative order inside both the even and odd groups should remain as it was in the input. So we need to return the answer within the time complexity of big O of n, and we shouldn't use any extra space, that is the extra space complexity should be big O of 1. So that's all about the problem definition, and so let's move on explaining the problem definition. So yeah, so the first step before moving on to solve any problem is to define the problem clearly. So yeah, so the problem definitions will be given an input as head of the linked list, and output should be odd group of the list followed by the even group of the given linked list. So this is the input and output. So what is the odd group? So odd group is nothing but the nodes in position odd. So the position 1, 3, 5, 7, etc. within the the size of the given list. So even group is nothing but the position of nodes in 2, 4, 6, 8, etc. less than or equal to n. So n here is nothing but the size of the given list. So these are about the odd and even group, and they have mentioned that the order inside odd and even group should be remain as it is. So the odd group should have list order like 1, 3, 5, 7. So this order should not change, like the position should not change, like one first 3 position comes and next one. So this is not accepted. So the positioning should be uh, the same. So this is the condition, and likewise in even group the position of node should be following the increasing order. So 2, 4, 6, 8, etc., and it goes on. So this is the condition mentioned here, and yeah, the first node of the list is considered to be the odd. So and second node is even. So let's consider the list given in our test case. So this is the list case which is given. So we need to group the odd and even pairs. So what we can do is firstly take the group the odd nodes. So second step is nothing but approach. So approach of our problem will be to firstly we'll group odd groups, that is we'll group odd nodes and even nodes separately. This is the first step, and the second step is to link the odd nodes last, that is odd group last, with even groups start. So this is the straightforward approach. So let's consider the given test case. So odd nodes here are nothing but when we group the odd nodes, one will take 1 initially, then 3 and 5. This is the odd group which we have formed, and it form the even group. So even group is nothing 1, 2 and 4. So we have formed the group successfully, and finally the second step is to connect 5 and 2. That is odd groups last node and the even groups first node. So we have connected them, and finally we return the odd groups start node. So the final group list will be 1, 3, 5, 2 and 4. This is the final list. So this is all about our approach, and how are we going to the approach in each step. So third is the steps to be followed. So we'll have 4 pointers, namely we'll have pointers of list node. So list node is the data structure for each node in the list. So we'll have odd start, even start, odd prev, and even prev. So consider the list just given in the question. So the case. So initially our odd start, let's say odd start is OS is null, and even start is null, odd prev is null, and even prev is null. So initially we'll the head will be pointing, let's say h as head. So head will be pointing to 1. So what we do is we'll take this current node and add it to the odd. So we'll go pair by pair. So we'll go pair by pair. If there is no pair, it's no problem. We'll consider that as is null. So we'll go pair by pair, and we firstly will take the first pair, and for each pair we'll take consider the first node as odd group and second node as even group. So one is belonging to odd group, so we'll check if the odd group has start or not. If the odd group start is null, we'll update current node as the odd group start, and previous of the odd group will also be current node. So we'll take move on to next node, which is event. So we'll check whether the event start is null or not. If the event start is null, we'll update the event start and also the event previous. So these are the odd start, event start, odd proof and event proof. Now we'll move on to next pair. So head will be pointing to 3. So in the current pair, this first node is belonging to even, that is odd group. So we'll check whether the odd start is null or not. It is not null. So we'll just update the odd previous. So before updating odd previous, we'll connect previous node to the current node. That is previous node of the current group, and current node is linked, and we'll update the R previous to 3. Now R previous is nothing but 3, and we'll go to next node. This node will be belonging to the even group. So we'll check whether the even group is null or not, start is null. So the even group start is not equal to null. So we'll just update the even previous value. So before updating even previous value, we'll link the previous value with the current value and update even previous to current node. Now we'll move on to next pair. So in next pair, we can clearly see that 5 belongs to even odd group, So we'll check whether our group start is null. It is not null. So we'll just update the our previous. So before updating the our previous value, we'll just link the value current value to the previous and update the or previous to current node. Now we'll move on to next node. We can clearly see that we have reached the end of the list. So we'll stop the iteration and the first step is over. So finally what we'll do is just link the or previous to the event start. So this will give us the final list, which is 1, 3, 5. So I have linked it. So 2 and 4. So we'll get the desired output. So this is the step. So I'm going to explain the each step clearly. So second step is to traverse over traverse list pair by pair. The first step is in for each traverse we'll add first node of the pair to odd group, let's say OG, and add the second node of the current pair to even group. So each pair will be having just two nodes. So we have a condition for both the nodes and we'll continue the process. So this process continues until every nodes in the list are traversed. So finally we link the odd start, that is sorry odd end, which will be in previous value odd through, link odd through with even start. So these are the steps we are going to follow and the time complexity for this approach. So for this the time complexity and space complexity, so let's mention this as complexities. So this is the complexities analysis. So in complexity, the time complexity of this approach is nothing but big O of n since we write it over each node, and the space complexity is big O of 1 since we didn't use any extra space other than the four variables. So whatever the input is given, so whatever the length of the input list may be, we are going to just use the four variables. So we are just going to use the four references. So that's all about our approach and steps to be followed in our approach. So now let's get into the coding section. There you will get the clear idea of how to implement these steps. So yeah, let's move on. So the first step is to initialize the variables. So we'll have odd start, even start, odd through, and even through. So initially odd start and even start, odd through and even through will be null. So each of the values will be null and we'll iterate over the list, right? So before moving on, there is a edge case in this. So in the given list is empty, we'll return empty. So if head is empty, which is null, we'll return null. We'll iterate over the complete list. So head is not equal to none. We'll go pair by pair. So we'll take the first node and we need to add this to the odd group. First node to the odd group, right? So if odd start is null, make on start as the current node, or else, and also we need to update the or previous value to current node, which is here, or else we'll link the or with current node, and or will be current node. So this for the first node, and we're going to do the same for the second node. So second node will be belonging to the event group. So we're going to just copy the same code and update. So we're just going to change those even from odd to even. So we have updated successfully. So before that, we need to check whether we have reached the end of the list. So this we are currently in the first node of the current pair. So we need to move to the next node, right? So for that we will be using move from current node to next node. So if it is null, it will mean that we have reached the end of the list. So we'll break it up. Otherwise, we'll add up the current node to the next, that is even list. So after adding it, we'll move the head to one position. So finally, the steps are over. That is 1, 2, 3, and 4. 4 steps are completed, and finally we need to link the nodes. So odd true with event start. So odd true dot next equal to event start, and finally we return the odd start. So yeah, using corner case, and we have 4 pointers, and initially every pointers are going to be null, and we're going to iterate over the list pair by pair. So the first node is to be added in the OR group. So if OR start is null, we'll update the OR start to current node, which is head, and OR true will be current node, or else we'll link the current node to the previous node, that is the last node, and we'll update the last node to current node of the R list, and same, we'll move using head dot next. We'll move one position, and after that, if we have reached the end of the list, we'll return, that is we'll break out from the loop, or else we'll add the second node of the current pair to the even group, and move the list by one node. So finally we are going to link the R will help us to find the last node present in the R group, and event start is nothing but the start of the event group. So let's take this up. So what problems here? So um, R2 dot next. So what is the mistake here? So let's print this up. So we'll try to print the traverse the R start, and traverse the even start, we are using this for test purposes. So we are checking for yeah, and the odd node is pretty correct. Odd group is properly aligned. So 135 and even node is not properly aligned. That is 2, 4, 5 is present. So 5 should not be present in the even node. So I think there's a problem in here. So what we'll do after this is if head is null, we'll make even row to next to be null. So event rule, yeah, this is a base corner case in which when we have the list node that is a list as odd length, we need to use this condition. So in order to avoid appending the last node to even list. So let's set this up. That's working fine. So let's submit it up. So um, yeah. So if even proof is not equal to null, this is the another base case. So we have missed out two base cases here. It is a corner cases. Let's submit it up. Accepted. And that's all about this video, guys. Thanks for watching this and have a great time. Happy coding.